Hey, what's up guys? My name is Cherno. Welcome back to another Cherno live stream. We are in for a quick one today. And it's also 2 hours late, so I apologize. Just had some stuff going on today. We're going to, first of all, we're going to get right into it because I think we've only got about an hour today. But we're obviously continuing work on the renderer, Hazel's new renderer. We are getting somewhere, but there was like, I don't know, I don't really remember where we left off, so this is going to be a good recap for those of you who may also not remember what we were doing last time, although if anyone is here that does know that, maybe they could remind me while I quickly tweet this out. But yeah, basically, as far as I know, I just remember it being kind of like, there's some major stuff working on, sorry, there's some major stuff to kind of change or kind of deal with. I think we were dealing with like some samplers and stuff last time. And there was did we fix that Vulkan validation kind of error? Oh, actually, I think we're going through the Vulkan validation errors. Yes, that's right. That's what happened. So basically, as far as I remember, we were kind of trying to get the, there was like some crash, or there was, I think when trying to draw quads, textured quads. Oh, no, but we did draw textured quads. Okay, you know what? Let's just kind of look at the code and run this and see where we're at. But basically, we had to like keep opening the Vulkan configurator in order to run it with validation, but then we figured out, I think the issue of why validation messages weren't printing, and the reason that actually was the case was because our log system was actually filtering it out. So because it was outputting them as like warnings, I think. So if we, just so I can show you what's going on, I think in Vulkan device manager, which we should, yeah, there's so much code here that's not used anymore. Anyway, Vulkan device manager, yeah, so we had this being output as warning, I think. Oh, well, I mean, it still is. We had, yes, I know, this is what happened. So we had, we were using HZ-Core1 tag, which is just a logging, part of Hazel's logging system. And we were outputting it at level warning, but also it has a tag, and the tag is renderer. And when you output stuff as tags, then the project settings actually, so when you load a project, in this case, I think it's just the sandbox project that ships with Hazel. When we load that project actually has the ability to define log levels, and it was just like renderer was set to error or something, which meant that because these were output as warnings, which we maybe should change this to errors. I mean, realistically, we can actually see what kind of message it is, because Vulkan can output many different types of messages, and they're not all errors. Some of them might be warnings, some of them might be like suboptimal things that you're doing. So obviously, like, I think longer term, we should probably do that. And then also, this is actually part of NVRHI, but it had like a bunch of possible things that you can actually filter out if you don't want certain messages that you don't care about being printed. But anyway, regardless, that's now set correctly. And so I think we should be getting, you know, as you can see, we are a whole bunch of various log messages here. So one of the issues I think that we faced, and now I'm kind of getting back to this, I mean, I believe there was either a crash or, it's not crashing anymore though, so I'm not sure what the crash I was remembering was. But I think if we, I mean, if we enable bounding boxes, that stuff still works. Oh, right. The crash is us having like a VK device lost error. If we, I don't know, sometimes when resizing or whatever, we just get like a VK device lost error, but you can see that we're doing some bad things here. And specifically, I think the bad thing that I wanted to focus on was the fact that I'm just trying to find it here so it makes more sense. Yeah, I mean, there's actually so much stuff here. We might just go through this today and see how many of these we can fix. That's probably going to be the smartest thing to do instead of just looking at some things, you know. I think this is one of the things. So, yeah, you know what? Let's just grab this entire block and I'll open up VS Code and we might just This is the Genesis server. Can we just, I guess we can close all this and just pop it here. We might, yeah, so we'll save out this message because that's important. And then this is the same, yeah, that's the Semaphore thing. So we'll see. There was also basically, oh yeah, this is it. I mean, this is pretty easy. But the other thing that we're doing, which is bad, is you can see VKQ submit. So we have a threading error where object of type VKQ is simultaneously used in current thread and, well, 2 different threads. So this is a very common error with Vulkan, and basically it just comes down to the fact that when you submit work, when you submit a command buffer to a specific queue using VKQ submit, then you have to make sure that's basically thread safe. So it has to be synchronized. You can't do that from multiple threads because then, you know, you're going to have an issue. So usually the way that we do that is we just have like, you know, like a mutex and we lock it to make sure that we, when we actually do the queue submission, it obviously doesn't occur while we're already submitting something else to that same queue. Now, same queue is a keyword because there are multiple queues that we have on our GPU. There's a graphics queue, obviously. There's the compute queue, and then there's also a transfer queue. And you also might have like, you know, multiple of each queue, although it's not that common. Like I actually don't know of any devices that have multiple graphics queues, but some have multiple compute queues, for example. So it can vary, but the point is that generally speaking, when you write synchronization for things like that, you would generally do it on a per queue basis. So you'd kind of have a mutex potentially for the graphics queue, the compute queue, and the transfer queue. Now, we in Hazel actually don't use any queues apart from the graphics queue at the moment. Mostly like a simplicity thing. We definitely should. You know, we should use the transfer queue for things like, you know, uploading texture data or buffer data. We should use the compute queue for compute operations, and we should use the graphics queue for everything else. But we don't do that at the moment, so this is going to be a bit of an easier fix at the moment. Not too much easier, but a little bit easier. And also, like the downside is that of us not using more queues is because queues can run simultaneously, right? So it's literally like a lane in a highway. We currently have one lane in our highway, and that's just the graphics lane. But if we had compute and transfer as well, transfer/copy, I think it's called in DirectX, so that's more common terminology as well. But if we had the transfer queue and the compute queue as well, it's like we got 3 lanes now, and we can kind of do things simultaneously on the GPU, which is great because at the moment our GPU is basically executing stuff one after the other since we're just taking advantage of a single queue. So that's kind of the issue. What's up, Double Truth? So that being said, let's think about how we're going to basically get rid of that error. And that's quite easy. And yeah, there's lots of stuff that we need to also fix here. A lot of them just happened when porting to NVRHI, but some of them were probably there kind of since the beginning. So meaning that they were actually there inside Hazel. But we just didn't really address them or whatever. Okay. And also remember, we're now using Vulkan 1.4, so it's probably going to pick up some extra things that have either changed or, you know, the validation layers didn't catch before, but now they've just expanded them. So that's why ultimately we should definitely go through like all of these and fix them all. All right, so the queue submission thing is kind of interesting. So the way that we can think about this little task is, you know, VKQ submit is basically the function that we use. It's not just, I think, that function though. That's ultimately the function, but because NVRHI, it's interesting that NVRHI doesn't just synchronize it for us. I'm a little bit surprised, to be frank, that that's the case. The reason why is because if we look at our render command queue, no, not this one, our render command buffer class, which now is the thing that actually does the submission. You can see we do device execute command list when we actually do the submission, I'm guessing. So there's begin and there's end. So we begin writing into a command buffer, we finish writing into a command buffer with the end function, and then we submit the command buffer or the command list for execution via this device execute command list function. And then that obviously takes us to NVRHI, goes into here. This would be the perfect place to probably do that synchronization because we have that execution queue in here. And it's like, why can you just not lock that queue or something? But either way, we go to device execute command lists, which, you know, unfortunately, let's have a look at where that's implemented. Vulkan device execute command lists, and then you can see it's going to do queue submit, right? And then queue.submit goes to Vulkan queue. And then here again would be a nice place to lock that. But over here we do actually have semaphores. So I wonder if they do queue to queue synchronization here. Which basically the idea is that sometimes, like at the moment, things are kind of easy because again, we just have that graphics queue. So this is like the graphics queue. So as we go down and we submit things, it's kind of easy. Like, you know, you're going to finish that before you do that, before you do that. Internally, Vulkan can reorder different commands, but ultimately the flow is kind of like this. But when you also have, say, the compute queue and it's doing tasks, sometimes you need to finish, for example, a post-processing pass in your compute shader before you can use that image to, I don't know, do something else, right? Or like, well, I mean, usually post-processing, you would just kind of present it. But let's just say that you have like a light culling system that runs on the compute queue, and then you need that light culling data in order to begin, you know, your main, you know, we have forward plus rendering. So your main kind of geometry shading pass, lighting pass would kind of happen once you have the light culling data from the compute queue potentially. So because you need that synchronization queue to queue, you would basically have a semaphore that gets triggered when that work gets done, and then you would have a queue submission waiting potentially on that semaphore, because semaphores are kind of GPU to GPU synchronization objects, whereas, you know, things like fences are GPU to CPU. So that's basically the way that you would do it. However, again, we don't have this at the moment. All of this work that we do, because we do actually have light culling, for example, that actually happens here on the graphics queue. So you don't have to do that because simple buffer and image like memory barriers will just suffice for this, you know, as far as I understand. You know, I'm not saying, I don't call myself a Vulkan or a GPU expert by any means. So even though I might sound like I'm saying everything with authority here, I might be wrong. But as far as I understand this, which is how my live streams usually go, that's like, you know, hopefully that goes without saying. As far as I understand this, that's kind of how it works. And semaphores, you know, we can use, you know, for this case. So that's why, like, you know, we have signal semaphores, which are important because this tracking semaphore, for example, is, I imagine, as we actually submit something to a specific queue, like the graphics queue, we have a semaphore, this tracking semaphore that, where does this actually come from? Okay, this is actually inside the queue. Represents a hardware queue. Cool. So internally, they kind of keep track of, they can keep track of when the work that was submitted here has actually finished. And you can do that via this tracking semaphore. So I wonder if you could then, like, you know, what that would actually be used for. Because by pushing it into this signal semaphores, you're basically saying that once this work is done, I want this semaphore to be signaled. But see, there's also this wait semaphore. So you can actually not execute this before something else is done. And you can see, like, we have wait semaphore. So I'm guessing we can actually, like, you know, add a wait semaphore, for example, if we want to submit some work to a queue, but then we need to know when it's done. Well, I mean, that's what a signal's for, but like, you know, we can wait on a particular semaphore if we need to over here from a previous queue. So that's cool. So I don't think it does anything automatically apart from potentially this tracking semaphore that, I mean, I don't know what else that's used for. Like, let's have a look. Update last finished ID, get queue semaphore. Okay, so that's what they call it, get queue semaphore. So yeah, so I mean, it just provides you with one because it might as well. And then you can use that if you want to just be like, so that you don't have to manually push a signal semaphore and then keep track of it. It just does one kind of implicitly for you that you can then retrieve. So that makes sense. That's fine. And that's on a per queue basis. So again, for us, really, there's just one of these objects at the moment because we don't have that compute or transfer queue in use. So that's like a little bit of an explanation as to how everything is put together and also what the problem we need to solve is. So because there is no kind of external submission, or sorry, internal locking or submission, I guess like render command buffer would probably be a good place to do that. Now, I'm also interested in the swap chain though, because the swap chain also is gonna do, well, so we have device execute command list null pointer here. Okay, this is just, we need to revise whether or not we actually need that, but that's probably it, isn't it? Yeah, so I don't know. I think that since we basically wrap, or we should be wrapping our like command buffers / command lists in this render command buffer class, we might as well add the queue locking here, because that way it's not gonna, like, I'd rather not, obviously I want to minimally modify NVRHI where I can avoid it, because every time I do that, we're more divergent from the actual repository. So let's have a look at how to do that. So, I mean, I'm just probably going to, the issue is that at the moment, this render command buffer, I don't know if we should have a separate one for each queue. Probably not. I think in the specification for this, which we don't currently have, you could probably specify what queue you want it to be on. And then we would have the appropriate mutex probably here. I think that would, I imagine that would make more sense. Yeah, because otherwise, yeah. Okay, so let's do this then. Let's do... I gotta remember how to do this. So we'll create a mutex. Probably don't even need to have a lock guard for it, because we can just lock the actual thing. So we'll just do, let's just do graphics queue mutex. So we'll just have this mutex, and then, really, sorry, we'll make it inline static, because we want this to be global. Let's make it an S. This is also something we could just have up here. I guess I will remove it from the header. So up here, I will have a static graphics queue mutex. And then over here, we basically, I guess we can just do it here. We just lock that, and then we unlock it. So you can just do it that way. You can also use a lock guard or whatever. I don't actually remember. Lock guard, like basically a spin lock is what I'm looking for. A unique lock, scoped lock. I think scoped lock is kind of what I was thinking of, but... And what's the difference? That's also that. So what's the difference between a lock guard and a scoped lock? Oh, here we go. Okay, to lock multiple mutexes using a deadlock avoidance algorithm. Right, so I guess lockguard is the simpler one that we can use. But anyway, I just don't know if there's any point. because I think internally it's just going to do that anyway. So we can just try this, I think. So if we just run that. Oh, I accidentally modified NVRHI. See, that's what I was talking about not doing. But yeah, that was an accident. Oh no, what have I done here? I think because I modified the header for this, it's like gotten all annoying. How's everyone doing today? Does those locks yield the CPU, or is it busy waiting? It's busy waiting, but the queue submission should be very fast, so it really shouldn't block the thread for too long. Yeah, see, this is the device lost thing that we keep getting. And I don't know why that is yet. And it's very, it's probably because of this, to be honest, because we're getting these intermittently. And also, yeah, so we'll fix those a bit later. I'm just trying to, I guess all I really need to do now is just look at the all of the validation errors that we have and just make sure that we don't have, oh look, we still do have the queue simultaneously being used by multiple threads. Interesting. I wonder why that would be. We must be doing this elsewhere. I mean, oh yeah. Yeah, we you know where we'd be doing it in the actual like in all the asset code, I think. Well, like image is probably the biggest one because I think we are, you know, for example, set data. You can see it's just calling it here. So really this should be using the transfer queue, obviously, but since we're not, it's kind of okay to not. It just means that you need to manage it. So what I'll do is basically, so we have this command list open and close here. I wonder if it's worth with a render command buffer. So we automatically create all of this stuff here. Yeah, that's okay. I think what we can do is, cause open, yeah, so, cause we're doing device create command list here. Well, we don't need to, cause you could be doing this every frame. So let's do this. Let's go, into here. We'll include render command buffer. And then inside image 2D over here, let's just do ref render command buffer. I guess you can call it command list. And then, yeah, basically the idea is, yeah, actually this is kind of an interesting concept. How about we just lazy create it, right? So basically if command list doesn't exist, then we can do, yeah, what would it be? Render command buffer create, right? Count. Yeah, we just need one. Image 2D. So we created it kind of lazily, I think. And then we would basically just rewrite this to being, I guess we would do RT begin. I'm not really that into, yeah, because for set data, I guess we would do RT begin. And then we would do end. So basically this does it immediately versus submitting it to the render queue, because we do want this, because again, when you're doing graphics buses, it makes sense to kind of submit stuff to like a render command queue, but meaning like a different thread to the render thread, submitting it to the render thread. But here, because we have the transfer queue anyway, and also there's not that much work to do here, we can just do it on the main thread, I guess, or on the calling thread, really. So we would basically do this, and then the right texture is obviously what we're trying to do here. So in order to do that, we would kind of do like, I guess, get active and then write texture. So we can do that there, and then we do RT end, and then we have to do submit, RT submit. And that's it. So that replaces all of this code. So it kind of looks like this. And again, what happens is if we what happens here is that if we sorry, what was I saying? Yeah, if this is, I don't know what I was saying, but this should be fine. And we just have to make sure that we find all the other instances of that. And basically stop doing that directly. So I guess we can do that by just having a look at device execute command list. Whoops. So if we have a look at where exactly we do this stuff. So Vulkan Swapchain does that there, which we probably need to possibly lock as well. Image still does it actually. Copy to host buffer does it. So I guess we do it basically everywhere. Yes, we need to replace it everywhere where we do it. So let's start with this one here. So I mean this, no, but this is doing a null pointer one. So what exactly is it doing? I mean, it's still doing it on the graphics queue though. So this is a special case, which again, I'm not sure that we need. It's just, it's running this to signal this, as far as I understand. And this was just something that was in NVRHI or in Donut, which is NVIDIA's little thing. Okay, so we still have it in image. So copy to host buffer does it, as I mentioned. So when we do this and set data, let's just also make sure that we do this. Really? That's surprising. Because didn't it work in the other place? Oh, it's a const function, that's why. I guess we can just mark this as mutable. Now this whole begin tracking texture state though, oof, I don't think we need that. I'll keep it here, but I really don't think we need that. Okay, so that should be that. Over here we will include this. since this is like, I mean, see here it's not needed, but here it is. But yeah, either way, we'll just do that. And that. And that. So I'll copy this because we'll have to do the same thing in vertex buffer. No, that looks identical. And we also have to make sure it happens here. And that's all good. Oh, they do the same thing currently. It's just a bit weird. We need to work that out. But yeah, that's the same. Okay. Storage buffer. Oops. Yeah. It's also got the offset here. Texture. So yeah, this doesn't do it anymore. And generate MIPS is not really something that we're doing at the moment. Okay, uniform buffer. Lots of different buffers. I wonder if we could have just combined them all into one class, kind of. I mean, we can. I probably should have done that, to be honest. Because you can see the code is like identical. Yeah, that's it. Yeah, but this gets submitted as well, which is I don't know, man. We gotta think about that. Okay, so texture still doing it, but it's kind of irrelevant. Pipeline is still doing it. I mean, pipeline compute is still doing it. And then Swapchain. All right, so I guess that's it. Really, this is the last one. Yeah, which do we still have that? No. I'll grab this. I think this we can actually create it here. what am I doing? All right. Cool. So let's launch it again and again. We're just looking for, oh man, I think we got some multiple. Or like recursive includes rather. Which is very annoying. No, well actually I forgot to include it here. I mean this shouldn't, what does this include though? I mean it includes pipeline. Alright, why does it include pipeline? Because of pipeline statistics? Yeah, well, why don't we bring that out of pipeline? Yeah, none of this, I'm usually quite into separating like stuff like this out because can't locate it for some reason. Because really, that's so weird. Because we end up with problems like this very often. So we can call this like pipeline specification or something .h. So this has all this stuff here. And I mean, yeah, it needs, I guess it needs some stuff. But hopefully not too much. And then this can just include pipeline specification. And then the reason why this is useful is because then if we're just looking for the bare minimum of what represents an object like that, then, and you could even have like a forward declaration of pipeline itself here, which could be useful. It means that when we are in here, for example, we don't have to include, or render command buffer rather doesn't have to include pipeline. It can just include pipeline specification, because in this case, it's not even after the pipeline. It just wants some of the utility kind of auxiliary structures. And that should help. So uniform buffer, you know, we just need to make sure that we include render command buffer everywhere. Index buffer. Yeah, we did. Okay, so let's do another build. Oh yeah, image. I mean, I'm sure we included an image. Let's try and maybe just get this compiling initially. $4,000 errors. That's crazy. Yeah, this is a recursive include, isn't it? It's the worst part of C++, honestly. Okay, I mean, the thing is we don't actually have to include this here. Like, we can just do a forward declaration. like this. And I got rid of the include, right? I mean, this includes vertex buffer, which is probably bad. See, this is another thing where like this does not have anything to do with vertex buffer, so it should probably be in the specification or something, because it's mostly utilities. Yeah, I mean, this actually can just be, let's do this. So this can just be vertex buffer layout. And then again, pipeline specification can just include vertex buffer layout, which is a lot leaner. And now hopefully this will compile. Yay. C++. Oh man. I mean, I never saw you live before. Thanks for being one of the major inspirations for me to get into engine dev. A few years ago, I'm currently getting my ass beaten by Vulkan. Yeah, Vulkan can be a little bit brutal when you're starting off, but it is not that bad. You just have to, there's just a lot to take in and a lot to learn, but it's, yeah, it's not that bad. If that's any motivation. You will get there. Just keep at it. C++ and its recursive includes, on the other hand, very annoying. Okay, so this is, I mean, this includes pipeline, right? I mean, I assume so. It's still building. That's weird. Maybe something else used to include pipeline and we stopped it from including pipeline and that was an issue. I was making a 2D game. I wanted to do everything myself. Ended up with making engine. Yeah, well, it's okay to have like, I mean, I mean, an engine is kind of just a framework. It can just be a framework that does things that you need your game to do, right? So like, it's even if your game, even if you're just trying to make a game, you're still gonna end up with engine-like systems in it. It's basically impossible not to. Okay, so let's have a look at this now that we are hopefully synchronizing everything. And the way we should see this is, yeah, okay. Unfortunately, we get that. We still have other issues, so. Okay, this is better, I think. Yes, so we loaded all of our assets, and basically, if I, how do I, no. How do I copy everything? There used to be, there we go, Control-Shift-A. So if we dump this here, basically, I'm just looking for that bug, or like that validation warning, and I can't really see it. What was it? I didn't get any. Oh, well, it was, look, threading error, here it is. Okay, so we're still getting that for some reason. But yeah, again, that could be, let's test this out first. Let's go to the swap chain and get rid of this and this. It's good that we have it here. So this was the threading error. I'll just save it in our like error list. Ruby. Ruby kind of has some nice formatting for Vulkan validation messages. So I'm gonna set it to Ruby. Okay. Oh, we're still getting threading errors. Huh. I mean, obviously we can, oh, well, look, qpresent KHR. Right. It might be the actual qpresent thing, which happens, I guess, here. Because we're doing this. Maybe this needs to be auto-locked. Oops. I mean, this is just qsubmit though. Where else could that be happening? That's so weird. We basically are not doing that anywhere else. So is it really the, but this is the presentation queue, which should also be different. Very strange. Yeah, that's so strange. Simultaneously used in that and that. That's weird. Just trying to think what else it could be. Because we should be synchronizing that now. Assuming that it all happens from here. The only two threads we've got running at the moment though, like, so this is the main thread and then the asset thread, but it's not constantly running. It's just during initialization. Like, it's just when it's loading the assets, it would be submitting stuff here. So this is the main thread. I'm just gonna see if, like, what the call stack looks like. Image set data. I mean, there's gonna be a lot of these. We should have a look at the asset What is an asset thread? Asset system. Try load data. So that's the only thing that can do it, I think. Oh, but it's not. What? That's weird. Let's quickly do this. Might not be able to print that easily. It's a uint. I just want to see what threads we're getting them from. I don't think we can handle printing it. That's why I'm type punning it here. Okay, I'll just be quick. No, I closed the log. I'm just looking for anything that's different, and I don't see it. So it must not be going through this system then. And certainly not when we're getting that validation, right? It's just always the same thread. Isn't that weird? Wait, what? Now it's not coming up with any threading errors. What? Maybe that's just a race condition. Let's try again quickly. What? Now I'm not seeing any threading error validation. What on earth? Let's try one more time. It's not coming up anymore. That's really annoying. Let's run it without the logging and see if it's still there. For descriptor sets, are you using shader reflection to get the descriptor layout or through code specifying how many buffers and where it's bound to? We use shader reflection to do all that stuff so that it's all like to create the descriptor layout, that's entirely done just via shader reflection. But then to actually set the data, we use basically strings. So the name of what you, like for example, if you have a uniform buffer and it's called something in your shader, you would use that string name to then set that through code to an actual uniform buffer. So your inputs and outputs are set like that. So I don't get it. There are no more errors somehow. Yeah, look, it's not happening anymore. Okay, that's weird. Now, I really want to deal with these weird ones, which is kind of this, I think. There's a queue_present KHR. Is that there's a queue_submit here, and here's one as well. So basically, we're waiting on a semaphore that has no way to be signaled. So let's investigate that a bit. So if we go into the Swapchain, apparently we're waiting on a present semaphore, which kind of makes sense, maybe. But how do they get signaled? So that's when we recreate the Swapchain, right? Destroy, sure. That's a bit weird though, isn't it? Why are we waiting on this semaphore? Oh, so we used to signal it here, that's why. So this is different now. Why are we even doing that? I really want to have a look at Hazel's old Swapchain. Let's see what we used to be doing in the Swapchain. So this is what we used to do. So we were waiting on image available semaphores, which are different though. And then we're signaling render finished semaphores, which really should be more like present finished or something, but anyway. Oh, and look, we were doing device lock queue here on the queue_submit. And then that, yeah, so that we used to do it on a device level, which is also, I guess, fine. And then we unlocked the queue after queue_present. Oh, but this was also a queue. Yeah, we gave the Swapchain a queue, which a command buffer, which we don't do anymore. So this is irrelevant. But yeah, this still is in that lock. So I guess we need to make sure we do that. And then in begin frame, when we do the acquire next image, do we have anything here? Probably, right? Yeah, so with the image available semaphore. So yeah, and what's this? This is an acquire semaphore. And this is a present semaphore. So when we acquire next image, we have a semaphore here, which is, yeah, our image available semaphore. For the current frame index. And that's what we wait on. Okay, weird. But yeah, I'm thinking that we maybe don't need this, and instead we just do this. And we wait on that. And then this whole present semaphore don't really know what the deal with that is. And what do we don't have a signal semaphore here. Oh, no, we don't need that. Ah, I get it. I get all of this now. So this is here to make sure that we've finished executing all of our command buffers on the graphics queue before we actually submit. So this is actually legit. And yeah, this also makes sense. So yeah, I think ultimately this is what we'll do. So we'll bring this back. We'll get rid of this. We'll bring this back. We need to do this. We just need to, so it's kind of what we were doing here. It's just we had a render finish semaphores, and then we did an actual queue submission while locked, and then we did the presentation. That's why it effectively worked the same way. But yeah, we still need a way to lock the correct queue here. So this is where things get a bit annoying. But I think what I can probably do is render command buffer. Or should that be in device? Okay, for now, I might refine this API later because it's a bit weird. But for now, what I might do is do a little static void lock queue and unlock queue. And then the idea of the idea here is that we'll just do basically this here and this here, and it is just the graphics queue at the moment, but whatever. And then we don't need this, and then we'll do lock queue and unlock queue. All right. And then that just means that from the Swapchain now, we can do render command buffer lock queue. We'll do both this and the actual, where's the presentation? Present queue. And then I'll unlock it here. So it's a bit, yeah, interesting, but that hopefully will fix that. Mineral Man, what are you trying to say? It's the problem's related to something relationally the same thing with weight semaphores. Yeah, but I think this is an actual like I think I don't think the validation layers are wrong here. Okay, sorry, let me try that again. Yeah. Okay, no, there's this as well. So, I mean, it fixed that one, but there's also some of this semaphore stuff, and there's something to do with acquired image indices, so this is now fixed, because we created that inadvertently, and then this is the same as that one. So we're basically down to this. This one seems to be fixed, but this one here is... So, queue submit. So the semaphore is being signaled by a queue, but it may still be in use by the Swapchain. Here are the most recently acquired image indices. So Swapchain image 0 was presented, but not reacquired. So semaphore may still be in use and cannot be safely reused with image index 2. So this is interesting. One solution is to assign each image its own semaphore, which we've done. Here are some common methods. So use a separate for them for per Swapchain image. Yeah, that is what we're doing. So what's the problem? Because we have this acquire, and again, I didn't really write this Swapchain implementation. This was NVIDIA, so there may be some nuances, but it kind of looks like we acquire an image. Here is the semaphore. And then we increment it. Should we be doing that though? Shouldn't this, I feel like this is wrong because the Swapchain index should line up with the acquire semaphore index, should it not? You can't just increment it. You can with this present semaphore because it's irrelevant, but this one actually has to correspond to this, I believe. So M Swapchain index should probably be the semaphore that you use. Well, again, let's have a look at how Hazel did it. It's funny because, anyway, whatever. That just sounds funny. But acquire next image, right? How did it deal with semaphores? So image available semaphores. Okay, no. So it actually did use current frame index, and then image index was something else. But we did use that for what? For current image index, which is different to current frame index. So this is in fact just a random thing. Image available semaphores. But where else did we use that? We use that as a weight here. But only in queue submission though, not in here. And then that was current image index. Yeah, which is this Swapchain image, Swapchain index. So that does actually look correct. And then, but with current frame index, what did, oh yeah, and over here we just incremented it by the number of frames in flight, which that's another thing. How do we know how many of these to create? Yeah, max frames in flight. I mean, this does +1 for some reason, but whatever. Oh, yeah, why does that do +1? Shouldn't that just be, maybe that's why, because if it's just doing +1, oh, it's set to 1. Okay, this is also an issue, I think. Yeah. Well, if we have 3 frames in flight, which I think we do, but what even controls that? I think we set it to 1 frame in flight at the moment, but either way, let's do this. Let's just get rid of the +1. I don't understand why there's a +1. Let's get rid of the +1. I honestly don't know what's going on there. We might have to do that. No, here it just clears it. Yeah, okay. Let's see if that fixed anything. No. And we're still, yeah, we got 2 here. That's very strange because we are literally doing what it's saying we should. Do I use AI to code? Not really. I talk to AI about programming topics, like as in mostly about how to do things and things like Vulkan and whatever else, but I don't really get it to write code for me because it's just not very good at it. Yeah. Yeah, so now this is fine because this increments by 1 and wraps around like this is legit now. And then we'll go through and try and do this with a semaphore, and I don't know about this. And then we have a presentation semaphore here, which is also fine. I don't know, it looks fine to me. It's got to be in the Swapchain, I think. Yeah, maybe I shouldn't have taken Donut Swapchain. I just assumed that it would be easier, but maybe not. Maybe I should have just rewritten our Swapchain, because this is our Swapchain, and it definitely seems to work. We've shipped games with this. Game Jam games, but still. Yeah. I just don't really know why it's complaining. Like, it seems fine. Because we don't really use that again, do we? No. Oh, you know what else? You know what it might be? Hang on. Yeah, because we wait on this before doing that, but that's... And here we're waiting on this. But yeah, again, this is for... Yeah. I think that's okay. What? How? Well, actually, yes, though. Maybe this is a new Vulkan thing. Let's try this. Let's try this. So acquire, that starts at 0, which is fine. Instead of incrementing it by 1, why don't we set it to the Swapchain index? Which will always be less than... Well, no, that's not true though. But yeah, but then again, we need it to be that. How do we know how many there are? We don't really. Let's just do like... To be completely honest, I feel like we should do a static vector. And we just have like 3. I don't think we're ever going to need more than 3. Then we don't need to do reserve. We'll set this to be 3. We can still do pushback, I guess. Yeah, or we can just do resize. We still need to do that. I mean, well, actually, you know what? Let's not make it a static vector. Let's just make it an array. STD array. That way we don't have to do the resize. This is 3. This becomes I. We just do that. Now, we need to destroy it. Don't see why we would have to do that. We'll destroy it. And that's it. And then we recreate them. I mean, we don't really have to, but whatever. Actually, in that case, maybe we should do that. Just to set them to a blank object. Okay, and now, yeah, so now that should line up. So if we just set that to the Swapchain index, then at least we won't get one semaphore being shared across multiple Swapchain images, hopefully. But we'll see how that works. I'm probably going to wind down the stream because I have to go. As I said, short one today. But if we can fix this, I'll be happy. Yeah, that looks like it's fixed. Let's try it again. Yeah, so that's interesting. We didn't used to do that though in Hazel. So as much as I'd like to blame Donut, I feel like maybe this is a new validation warning in Vulkan 1.4. I don't know if it actually is, but you can see we're not getting that anymore. So all the validation warnings we now have are fine. So the big test now is, can we run this without crashing? Like as in, can we run Hazel without a device lost or whatever? Which, oh look, here we go. Oh, so it's only after we click no. So now we are probably gonna try and load from multiple threads. So I wonder if that works. Yeah, now we have some like draw indexed and whatever else, but I'm just checking for those same ones. Let me just search for Semaphore. And you can see we got. Can you see that actually? No, you can't. If I zoom in, you probably will. No results. No results. Okay, so that's fixed. Cool. And then everything else I don't care about, we'll deal with that on Wednesday probably in the morning. Because all of these are fine. And yeah, so we shouldn't really crash anymore, right? Like, because I'm guessing the crashing was to do with the semaphores and whatever else, because it was a driver crash or a device crash. Or just try and, you know, resize and do some stuff, you know. Yeah, we seem to be working pretty well. Got that pink clear color for a bit. I should probably make that black. Yeah, sweet. All right, awesome. So we fixed some Vulkan validation, had a quick, short, productive stream. Hope you guys enjoyed this. Bustarov, spasibo, thank you. Gesundheit, danke. I happen to speak Russian and German, so it works out pretty well with you too. Thank you guys for watching. Don't forget, you can go to patreon.com/thecherno, help support Hazel, get access to all of it instantly, and the streams will be uploaded to my Cherno Unplugged channel on YouTube, so you can follow along. Probably will publish one tonight, hopefully, as well. Thank you guys for watching, and as always, have a good day or evening or whatever else. Raid. Yeah, we could raid someone. I haven't done that in so long.